Dear Xpeng owners, dear friends from media, ladies and gentlemen, good evening to you all. Welcome to Xpeng Tech Day 2022, also known as 1024 Day. 1024 is 1K. As all software people know, I started out as a software engineer. So I always believed that we can change everyone's life for the better through technological innovation. And this has always been my intention and motivation from the start of my career to entrepreneurship and to entering a brand new industry of automaking. So 1024 has inspired me. 1024 has pushed me, including pushing Xpeng. I believe that using technological innovation to satisfy customers will definitely make our life better. So, in today's event, I would like to first and foremost quickly review with you the content of our last 1024 Tech Day. The first part is about supercharging. As I shared with you last year, we expected to make the charging speed twice as fast as the current speed because we found that it is very painful when you drive your car to a supercharging station. You have to charge for 40 minutes or even an hour or more to finish the charging cycle. In fact, this is what makes it so different from the traditional refueling experience. Can we make it faster? 5 minutes, 7 minutes, or 15 minutes, and for a longer driving range? And we're very happy to announce that starting from G9 and all our future models, we'll be able to make super fast charging a reality. After the mass production of our 800-volt high-voltage silicon carbide platform models, our future products will be equipped with 4C, 3C charging capabilities. The second part is about our City NGP, which is the first mass-produced urban scenario high-level assisted driving in China. Speaking of this, I have quite a lot of stories to share. I'd like to, first of all, talk about two things with you. When I first started using our City NGP, I complained a lot because it was like working with a new driver who had just learned how to drive. When I first started using the function, I was honestly quite apprehensive, and I was ready to take over at any time. I thought to myself, is it really safe? Is it comfortable? Is it a good experience? But recently, when I started using our fourth version, which is scheduled for OTA at the end of the year, I felt for the first time that it was like a slightly more skilled driver that was helping me to drive. And the feeling was completely different. That was the first time when I really went from believing to having a real physical feeling of what it would be like. If this function can be used nationwide and across all scenarios, I believe it will be a huge change to everyone's traveling and driving experience. And this is the first point that I would like to share with you. And the second thing is that we also encounter great difficulties, which means that City NGP really relied on high-definition maps. And to be honest, we didn't think at all at the beginning that we wouldn't be able to launch it as soon as we thought. We thought that we could launch it in the first half of the year or maybe late in the first quarter, starting from one city to a few more. And by the second half of the year, we should be able to roll it out to a lot more cities. However, challenges turn out to be a lot more than we had thought. And regarding how we plan to solve those difficulties in the coming year and what we plan to do, Xin Zhou, our next speaker, will be able to share with you more information. So today in my presentation, we are going to cover 4 parts. The first part is intelligent driving, the second part is intelligent interaction. And the majority of today's event will be focusing on these 2 parts, followed by our thought and our latest update regarding robotics and flying cars. Now, I would like to invite Dr. Wu Xinzhou, the Vice President of Autonomous Driving here at Xpeng, to share with you our stories behind intelligent driving. Hi everyone. How time flies. I can't believe it's another tech day again. And I'm very happy to be here today to report to you our latest update and also meet with you to talk about the latest update and the progress that we were able to make for the past year. As was mentioned by Xiaopeng, last year we set out a goal to actually roll out our City NGP. And for the past year, our whole team, including a lot of colleagues in the whole company, including Mr. He Xiaopeng, all of us have made great efforts to conquer all of those challenges. There's been a lot of technological challenges as well as regulatory challenges. We have been working together relentlessly in order to really roll out the City NGP as a high-level intelligence driving functionality. After our efforts, we were able to achieve a great result, which was that on September 17th, City NGP rolled out in Guangzhou, which was an industry first. Although this is just one city, and also, as was mentioned by Xiaopeng, when our software was delivered, as a customer, he still felt like there was still a long way to go before approaching the proficiency level of an experienced driver. However, I believe that when we look back in a few years' time, this event, the rollout itself, will still be a unique experience and an important milestone for us. First of all, for our users, they can use a high-level assisted driving capability for the first time in their most high-frequency scenarios. And then, from the perspective of the industry, the rollout itself also proves that such capability is achievable despite the restrictions, balancing the cost of hardware and software of our current mass-produced vehicles, our technological challenges, as well as the laws and regulations related to government policies, as mentioned earlier. Therefore, in addition to Guangzhou, in 2023 and 2024, we definitely are confident that City NGP will be able to cover more cities, and our users from across the country will be able to enjoy a high level of assisted driving as soon as possible. And we look forward to seeing everyone experiencing the charm of such functionality. During the whole development process, actually a lot of people who care about XPeng's development and a lot of our friends who support us have given us kindly advice. They really are curious and confused as to why we chose to focus on City NGP at this particular point in time, rather than focusing on some simpler scenarios that generate more short-term benefits. They are right in a sense that there's a lot of technological challenges in developing City NGP. For example, there are complex urban road conditions, one-way multi-direction or multi-layer streets, variable lanes, complex intersections, difficult positioning and navigation due to high-density blocks and buildings. Also, lane lines quickly wear off, and we commonly see traffic irregularities and violations. In addition to that, we have road closures due to frequent constructions or maintenance activities as well. For example, by the end of September 2022, there have been approximately 500 road construction projects in Guangzhou based on the city municipal's announcement. Basically, that means 2 constructions per day so far. So definitely this is a super complicated and constantly changing environment with lots of different traffic participants. Compared to Highway NGP, if we have to quantify the difficulty level, City NGP is 100 times more challenging. The reason why we still chose to develop City NGP is because of the first principle thinking, or really that we have long-term vision. City scenario is the most frequently used and the most essential scenario for our urban users. Here are some numbers. Urban driving accounts for 71% of our total driving mileage, and in terms of the duration, urban driving accounts for 90% of our total driving. Therefore, understanding urban driving scenarios is essential to achieving success in autonomous driving. That is why, for the past year, well, to be exact, we've spent 18 months in the past in the development of CityNGP. In order to quantify the efforts that we've put in, the lines of code for CityNGP is 6 times that of Highway NGP, which means that it has an increment of 500% compared to Highway NGP. And you can also understand this from the perspective of the development volume of CityNGP, which is 6 times as much of that of Highway NGP. And of course, this is a simplified comparison, specifically for perception, because we need to identify more objects in city scenarios and track more targets. The number of our perception models has also grown by 4 times. And the other aspect of comparison is in relation to the behaviors of different vehicles on the road and also the prediction of the behaviors of the cars around you. So the planning of the behavior that is involved is an astonishing 88 times more compared to Highway NGP. This is also consistent with the conclusions that we made just now, that the CityNGP is 100 times more challenging than Highway NGP. Now, specifically speaking, what have we done for CityNGP? Actually, we can look at it from 2 dimensions. I think the first dimension is the capability of handling different urban conditions to deal with complex traffic environments, including various traffic participants, including ourselves as part of the road condition. The first example is that we have added some lateral control capabilities in city scenarios. The most common thing that you may see on a daily basis is quick cut-in. Now, in this case, you have 2 options. The first is to brake really hard, and the other option is to do a lane change. We have seen from the slide here that there was a very beautiful lane changing action, slowing down slightly, leaning to the side. I think this is really the city scenario 101. And the second scenario is also very common that requires a lot of negotiation, especially when we are driving at a low speed. If you want to change lanes or if someone else wants to cut into our lane, the situation requires some negotiation between the 2 parties. In this case, we would call it an interactive structure that we introduce. In this case, we have introduced in an interactive structure into our algorithm, especially in terms of the prediction of nearby vehicles and in the planning of our own behavior. We will not only predict what the vehicle will do next, but also how they will react when we do A or B. In this way, we will be able to gather all the information, make a comprehensive judgment on what we should do next. And the third scenario is also very common, which is handling uncertainty. Now, for example, this car has been driving along the lane. Does it want to cut in or not? So in this case, we are trying to predict each vehicle around us, in addition to giving some certainty to that kind of behavior. Now, it's very likely that the car is going to stay in their own lane, but it's also possible that they are going to cut into your lane. To make deterministic predictions and uncertain predictions, we call it caution, which means that we are going to differentiate different predictions. The priority is to maintain the highest level of safety. So with that premise, we try to make the driving experience as comfortable as possible. And that has been reflected on the latest update on our software that Xiaopeng has seen for the past few months. And all the steps are embedded in the details. An important aspect of our behavior, our capability of handling, is to react to different mapping situations. One example is that when you have a static obstacle on the road, this may be only a temporary small change to the map, could be some traffic cones or water barriers. Then in this case, we need to allow the car to execute a sidewalk as soon as possible, and then again, we need to make the experience as comfortable as possible. Of course, there are some more difficult scenarios. For example, the maps that we're using may look completely different from the actual traffic scenarios due to road construction or renovation. In that case, we will detect what is happening and we will downgrade to LCCL function using our cameras to pass the road. After passing that part of the road, we'll return to the CityNGP. Coming up in our next session, when we talk about our full scenario, I'm going to go into the details of how we make such a switch between different modes so seamlessly that the user or the driver doesn't really feel it. Right now, it still creates some obvious physical sensation during the switch. The third situation related to the map is actually some big intersections. At such intersections, it has a big issue, which is that most of them are not marked. And when we are driving past these lanes, we have to fall back on our usual driving habits. There may be some virtual lane lines in the map, but if you follow this geometric trajectory to drive through these virtual lane lines, there may create some big issues. Therefore, in such scenarios, we will completely erase the geometric information on the map, and according to what we call the traffic flow on the spot, or according to the driving state of the vehicle, analyzing the logical relationship between each lane to determine what we should do. Therefore, as you can see from the slide here, that in the urban scenarios, the core capability is lateral movement. It is very often said that assisted driving or autonomous driving on high precision map is like driving a tram. In fact, what I would like to tell you is that it is impossible to use the logic of a tram to develop city NGP or high-level assisted driving in a city scenario. If you want an analogy, you can imagine that the rails of the trams are still there, but there's only rubber bands that are connecting different vehicles on the rails. The rails can tell you where you should go logically, but the core capability of City NGP is to determine how far off you are from the actual track of the tram based on the perception capability of the car. Now, to describe the developmental process, I think arduous would be an understatement. We're starting pushing the function to our employees on September the 17th, and after the first week of October, on October the 8th, we launch a public beta test, which means that we make the function available to our car owners in Guangzhou. And a couple of days ago, we made available our next iteration of the software across the country. And in the past month, we've collected some useful data that I will share with you here. Actually, the data is quite in line with our expectations, which means that with such a high-level assisted driving capability, in such a super complex scenario in the city, at least our willingness to use City NGP or assisted driving has increased significantly. The first figure is the penetration rate of assisted driving in urban scenarios, which has reached 84%. It means that the probability of users using urban assisted driving every week is 84%. What does that mean? It is about 3 to 4 times higher than the adoption rate of our LCC. Another figure which is also very important is our mileage penetration. Right now is 63%, which means that of every 10 kilometers of city roads where City NGP is available, 6 kilometers are assisted by it. So this is definitely a huge encouragement and a boost of confidence for us. Our current driving efficiency compared with human drivers and the general time frame suggested by navigation is about 90%. Of course, this is definitely not good enough for us. We will continue to work hard, and hopefully in the next OTA and also the full scenario assisted driving on G9, we can show you an even bigger improvement. The average driver intervention per 100 kilometers driven is about 0.6 times. This is very close to the level of our highway NGP. When I saw the data, to be honest, I was happy and even proud. City scenario is just too difficult, and it's definitely not easy to arrive at where we are now. The implementation of urban driving assistance is definitely a decisive step into the second half of the autonomous driving race, where we're going to start with full scenario driver assistance. What is full scenario? I actually have prepared a slide for it coming up. We hope that through the construction of full scenario assisted driving capabilities in the coming 2 to 3 years, we can fully support all scenarios. At the same time, we hope to cover the mapped and unmapped areas and be able to keep resolving corner cases in the second half of the race, moving assisted driving really to unmanned driving in the future. We hope that full scenario assisted driving, as made available on all G9 and Orin platform models, will be the ultimate form of assisted driving before driverless driving. Starting in 2025, we'll have new hardware models and our software capabilities, and hopefully by that time, we will also reach a mature state of development and we can officially move forwards to full autonomous unmanned driving. Okay, so what is full scenario assisted driving? I think a simple way for people to understand is maybe a comparison with XPilot, the system of assisted driving that we have now on the Xavier platform of P7 and P5. In XPilot, of course, we cover a lot of it today already in terms of city NGP, in urban scenario, and also on the highway. We have launched the highway NGP early last year in 2021. We also launched our valet memory parking last June. In scenarios where there's no high-precision map coverage, we also have the LCC road centering assistance as a capability. Now, our next generation of full scenario assisted driving will be named XNGP. I believe that this slide can help you to understand the concept. First of all, in the scenario without a map, with the release of XNGP capability, we hope that it can approach the current city NGP capability. The user experiences should be consistent with or without a map. In the parking lot, we will upgrade our valet memory parking, and it will be assisted driving in the parking lot scenario, which means that we are going to have the navigation capability and also rerouting capability and complete point A to point B travel within the parking lot. And in the two scenarios of highway and city roads, our capabilities can also optimize our experience significantly, especially for highways and expressways where the adoption rate is very high. We hope that we can empower our highway and expressway scenarios with the capabilities that we have learned in the urban scenes so that we can basically achieve zero driver intervention on highways, which is one of our goals in 2023. And for city scenarios, with the complete release of the hardware capabilities of our next generation hardware platform and the further improvement of our software capabilities, we expect to see a huge upgrade in capabilities as well. The main goal is to approach the skill level of an experienced driver and even surpass them. This is our goal for XNGP in the last quarter of 2022 and for the year of 2023. Such a powerful function must be backed by a very strong system capability of autonomous driving. As we mentioned earlier, on Orin, a hardware platform that we use for our flagship G9, we have done a very big upgrade of the sensors and the central processor of computing, especially for the ECU, which has been upgraded from the original 30T to 500T, a nearly 15 times increase in capacity. At the same time, we have also made a corresponding overhaul on the software, so to speak, especially to support the coverage of unmapped city roads. We have also improved our overall AI capabilities as well. At the same time, under the waterline of the iceberg, in fact, in the past few years, including in the coming 1 to 2 years, we will strive to create a so-called fully closed-loop, self-evolving AI data system as well. Coming up, I'm going to give you more information systematically. Well, let's start by talking a little bit more about our software capabilities. In terms of our software capabilities, the main thing that we're going to do, as mentioned earlier, is to launch our new generation of perception architecture, which we call XNext. Unlike the previous generation of software, where we have the AI capabilities based on single frame of multiple cameras to do deep learning, neural network, and then through a lot of logic and algorithms and computing, and with the fusion of information mentioned, we are able to produce 360-degree perception, but for XNet, the keyword is multiple camera and multiple frames. We will inject the video streams from each camera directly into a large model of deep learning network and directly export static and dynamic output in 3 dimensions. Especially for a static environment, we'll have super powerful environment perception ability. Simply put, it's like we will have the ability to generate high precision map in real time. On the picture here, you can see a simple example. We are looking at a car passing a traffic circle, which is this cute little red car that we have here. Now you can see that the lane lines here, they are not from high precision map. They are generated by our real-time perception output from XNet. It's not just the lines, it's all kinds of other things that you are looking at. Stop lines, sidewalks, etc. So in the future, we will be able to utilize this to overcome the unmapped scenario and conduct high-level urban-assisted driving. We also have a stronger 360-degree perception for dynamics. In fact, for our first generation of perception fusion architecture, we encounter some challenges. You may not expect that the most difficult places is where it's the nearest to the car, because in the place closest to the car, for us, no matter what sensor we use, there are blind spots. For LiDAR, there's a blind spot close to 1 meter. Millimeter wave radar also has a large blind spot in close proximity. And the camera has a distinct boundary in many places because of its dependency on single frame and single camera methods. With XNet, we are doing the equivalent of a pre-fusion dynamic object detection. Now we can see that a significant improvement of our capability focus on recognizing a near-vehicle object. We believe that we will have more stable near-vehicle object detection, which means that our negotiation capability will be stronger and your success rate of lane change will be higher as well. For our dynamic XNet, it actually has an impressive ability. What is this about? It not only is able to detect the position of the object, it's also able to detect the speed of the object and even a prediction of the future trajectory of the object, which is very impressive and powerful. Especially for millimeter wave radars that usually have some weaker spots and scenarios, especially in near car area where we have some vehicles crossing in front of the car or from other lanes, it would be very difficult to detect, especially the lateral speed of those vehicles. But with dynamic XNet, we can actually detect the speed of these objects without difficulty, which is a huge enhancement to the millimeter wave radar. Then where the original millimeter wave radar may already be powerful, we can actually create redundancy. By doing so, we can improve the overall safety for our urban scenario. Such a powerful XNet is backed by the latest transformer-based network architecture, but it's actually very difficult to deploy such a network on our software. Let me share some figures just to give you an idea. The first one is labeling. In order to train such a video input network, we may need about 500,000 to 1 million short videos, of which the number of dynamic targets may be hundreds of millions or even billions. According to our statistics based on our current annotation team's efficiency, we estimate that this could be a workload of 2,000 person years. What does that mean? For our current 1,000 people team, this may require an entire team's effort for 2 years straight. Completely unacceptable. Then from another point of view, training. Even with one of the best servers, the training time for a single machine takes almost a year. And then, even if we do not do any optimization, if we just directly deploy the network on Orin, it will require more than one Orin, even though one Orin its computing power is already very strong. It requires more than one. So how can we meet such a challenge and be able to deploy the network of large models smoothly? As a result, we have done a lot of work in the past 6 months. The first one that we deploy is our fully automated annotation system. We have improved our annotation efficiency by 45,000 times through our algorithm. The original 2,000 person-years of work through our system can be completed within 17 days. This is very astonishing. I would like to highlight that this auto-labeling capability is not only used in our data collection, where we have a modified wearable 360-degree lidar on the head with point cloud data. We can also use the system to label all the data returned from our current front-mounted mass-produced vehicles cameras. So this is very important for us. In terms of training, we have officially announced a while ago that the largest autonomous driving computing center in China has commenced operation. It's called Fuyao. We partner with Ali Cloud on Fuyao, and Fuyao has a computing power of 600 petaflops. You can see it as putting together thousands of Orin on one single training platform. And we can actually reduce the training time of nearly a year, 276 days, to 11 hours, which is a 602-fold increase in training capacity. And finally, a word about deployment. In fact, we just mentioned that XNet requires 122% of the computing power of one Orin. First of all, Transformer is a very new operation that has very little support available even on the Orin platform. We got it through our Xavier platform, and we can say that it's a deployment that is very unique, and we have a lot of accumulation in the deployment experience, so we did a complete reconfiguration of the whole transformer operation, and we have got basically 2.9 times higher gains in the overall runtime through the reconfiguration of transformer. But if you look at the transformer, which is the green layer in the middle, it is about a 20-fold reduction of its computing time to 5% of the original. In addition, we have a 2.6 times acceleration of the computational deployment through the model pruning, and finally, we have a 1.7 times acceleration through a collaborative optimization between each GPU and DLA. So we took the original computer power that required 122% Orin, and we did it with 9% computing power. Now, we have just talked about how our overall XNet is implemented on Orin, and then XNet is a very significant algorithm for our next upgrade from CityNGP to XNGP. But behind this, I would like to actually talk about our fully closed-loop self-evolving AI and data system. Now, for a closed-loop data system, you probably have heard that there are about 4 important steps: collection, labeling, training, and deployment. And just now, we have already talked a lot about labeling, training, and deployment through XNet implementation. And in terms of data collection, actually, we have nearly 100,000 cars that can be used to complete such a task. And we have made a lot of effort in the past 2 years to complete this closed loop. Now we have deployed over 300 triggers in our user's car, and you can go ahead and determine what kind of corner cases is useful to our system and then upload them. And we can even decide what kind of data we need to collect each week from the fleets by our cloud deployment. And the data source include visual, dynamic, static objects outside of the car, and also full stack data. In the past 6 months, we have made a major upgrade to our closed-loop data system for basic capability improvement, so this may seem much more complicated. I would like to highlight 3 things. The first one is the golden backbone model in the middle. which we have introduced in the past 6 months. And it is probably one of the most important innovations. With the introduction of Golden Backbone, we can now form a small closed loop on the right side, because Golden Backbone is based on a combination of self-supervised and unsupervised capabilities. As long as there is data coming in, the right loop will keep optimizing the base network. With such a base network, another advantage is that we can decouple the improvement of the basic network capability and the training of the release model. So when we need to release the model, we can use the existing base network to do a small amount of optimization instead of using the training from the beginning. If we can decouple these two parts, we can get a greater improvement in efficiency. Now, the second change, as you can see here, is the ability to generate simulation data. Our simulated data is as good as authentic data, and we can collect more corner cases. Later on, I'm going to give you an example. The third point is also very important, which is that once we have such a large amount of data, we will also use the actual data to do large-scale data simulation and continuous integration to help our software keep iterating forward. Later on, I'm going to give you more explanation. All right. Next, I will give you 1 or 2 examples to illustrate how this closed-loop data is done. If our test car or our user's car discover that our network may have an undetected case, by the way, this is just an example. This problem has long been solved, so don't worry. Now, this example can be only seen maybe every 1,000 kilometers or 10,000 kilometers, but in fact, in Guangzhou, this is quite common. So I'm really impressed by the innovation of our drivers here in Guangzhou, because they can utilize the loading capacity of this tricycle fully. But when our network first sees the case, it would be very surprised. So this will be recognized as a corner case recorded into our system. And then with this corner case in, we would be able to do a dynamic deployment in the cloud to find or locate similar photos. Now there are only 9 photos here. We don't want to overwhelm you, but actually it's very easy to spot this kind of photos in Guangzhou with thousands of similar scenarios, all added to our database to complete the entire model training and solve the corner case, by the way. Now, this is a very simple and straightforward example of how we use data to complete the corner case solution. All right, next we'll probably look at a more extreme example. Now, this is slightly exaggerated, but it's a real case from the data that we collected from our fleet. At least from my personal experience, I've never encountered this kind of case. I don't know about you, but this is probably once in a million kilometers. This is a big truck. It's got a wheel off, and there is some friction that caused a fire on the wheel. So with such an example, suppose that there is a corner case. How do you actually solve it? Even if we deploy 100,000 vehicles to collect the data, it may take several years to collect enough data. So this is where our simulation capability comes in. Now, this is based on our current UE engine. You can see here that our UE engine is actually used to make Hollywood movies. It really can fake the real, and it can be presented to us with multiple camera views completely together, and it actually has more to offer, which is that it has ground true value, which means that we know where the car is, we don't have to annotate. With such a capability, we can generate thousands of similar cases with all kinds of vehicles with their wheels off. Now, with this kind of capability, we can get a good solution for some of the rarer corner cases, which may be cases that we never encounter at all. In addition to our large-scale simulation verification and continuous integration capability, well, by the way, these data are actually real data. In fact, every line of code change we make before we merge it into our main code base, they have to go through simulation tests of 50 million kilometers, because we know that it's very costly to have rejected or returned code. We definitely do not want our fleet to be unsafe on the road. We need to avoid some low-level errors as much as possible. So we run the codes to verify the change through the 50 million kilometers test. And also, we have 5,000 core scenarios that they must pass. We also have a library of over 17,000 special scenarios. These cases may or may not pass. We'll determine through a comprehensive set of indicators, and it's through this simulation capability that we can have our code and our overall software capability continue to iterate forward. Just to summarize, we use a very powerful system capability. Of course, we're constantly improving our efficiency, and then we can make our software more advanced. And the core goal is just to provide our users with a smart driving experience that is better, more advanced, and more enjoyable to use. Well, finally, let's talk about the XNGP development plan. So in the G9 Max version, including the next generation platform with Orin as the core, will include all the leading features as mentioned before, including Highway NGP, VPA, LCC, and APA available upon vehicle delivery this year. And in the first half of 2023, well, actually, in the beginning of 2023, which is January or February, we'll have the City NGP available on the G9. By that time, we hope that we can cover Shanghai, Shenzhen, and Guangzhou. In addition, we'll enhance our unmapped scenario capabilities, which is the LCC coverage scenario, to the level of our first generation XNGP capability. We hope that in all unmapped cities nationwide, we can support lane keeping, recognize traffic lights, and can start and stop, which is what we hope to achieve in the first half of next year. And in the second half of next year, we hope that the majority of our unmapped cities can have the ability that approach City NGP. That's one of our overall XNGP development goals. And in 2024, which is another major goal for XNGP, we would like to integrate all scenes so that our users can experience a seamless and smooth experience of traveling from point to point. Coming up, I would like to talk about XPilot. Now, in the Pro version of G9, we will have the leading features we just mentioned upon delivery in 2022 and 2023. And then in the first half of 2023, we'll support traffic light recognition and lane level navigation. For the P version of P5, which is our high-end version, with lighter version, we'll also expand the City NGP to support at least 3 cities in the first half of next year. Because of the laws and regulation of other cities and low visibility, we will need to see how fast we can follow up with the launch of new government regulations. And then we'll have the optimization of Highway NGP strategy in the second half of next year. The E version of P5 and the E version of P7, which are the high end of our P7 and the medium version of our P5, we aim to support traffic light recognition and lane level navigation by the first half of 2023. And then in the second half of next year, we'll be able to complete the optimization of Highway NGP strategy. Now, what we can guarantee our existing car owners is that when we have every bit of capacity and enhancement, if hardware allows, we will consider integrating it back to our Xavier platform. Actually, about XNet, across our current Xavier platforms, we have done a lot of optimization. For example, using cameras and time domain information to identify the speed of object, This is already done in P7, even though it's a reduced version. We do it because we want to better capture static objects, because as you know, this is a long-term challenge for L2 systems. We have also seen that there's a huge change. Actually, in fact, this is one point that I forgot to mention. Through the closed-loop capabilities of corner cases, we have increased our overall highway NGP safety level by 20 times for the past year. Actually, since the release of the function, it's been a year and a half. Because we have monitored data in the back end, the accident rate per million kilometers is reduced by 20 times. So we will continue to feedback as much as possible to our existing models. Now, one more thing. I would like to talk about our robotaxi. Our G9 has just passed the closed field test for autonomous driving. This is actually very impressive because G9 is a mass-produced, unmodified commercial car. And we have not added any new sensors, and we are able to achieve the same kind of capability as the cars that you usually see with a big lidar on their heads. Thank you. Now, when we look further down the line, with the G9 being able to get such a license, we hope that we'll be able to commence our robotaxi operation in Guangzhou. Of course, there will be safety officers, and of course, we will take passengers. Through such an exploration, we hope that we can identify the difficulties of robotaxi scenario as early as possible, and then we can form a good mutual feedback mechanism with our main line of assisted driving development. For example, our assisted driving can be fed back to our unmanned driving, which is our robotaxi fleet. And the large amount of data of robotaxi can be fed back to our assisted driving as its capability enhanced as well. We hope that by 2025, our software capability, including the accumulation of our robotaxi capability, our hardware, can align with the software. And by that time, we will really approach high-level autonomous driving. That's all for my part of the speech today. I've been with the company for 4 years. And in general, I think I came to the right place at the right time. And I'm committed to taking the right path, even though it's very difficult. I believe that we are on the right track. And I'm convinced that as long as my team and I, and also everyone here today, work together, we'll be able to reach the inflection point of intelligent driving, where the users will be willing to buy our features. At the same time, if we look further, we can work together to liberate humans from the task of driving. Thank you all. Next, I'll give the floor back to our CEO and chairman, Mr. He. Thank you. I'm actually convinced that next year, high-level intelligent assisted driving will allow us to enter a new era, so that we can really drive more easily in the city and highway scenario. I think easy is a very important word for me to describe intelligent assisted driving in the future. So here, I would like to continue to talk about the first part of intelligent interaction, which is our intelligent voice assistant. Now, XPeng has done a lot of exploration. When we first saw the large screen, we wonder if the future of interaction mainly focus on the screen, or does it come from other means? When we first explored pure functional voice interaction, well, actually, it was the year before last that we started to enter the full scene or full scenario voice system 1.0. And we are very happy and fortunate to see today that according to our data, voice interaction matters more compared to screen interaction. When intelligent assisted driving enter a longer and larger era, voice interaction will matter more. Let me introduce to you the full scenario voice system 2.0, which is the first of the industry's whole car, always ready human-machine interaction system. There are several features. The first one is full-time dialogue, which means that when we use our voice assistants before, we had to wake it up. But for the new system, it's always ready. You don't need to wake it up. And the second thing is that previously, when the driver wakes up, the assistant, the co-driver, will need to re-wake it up if they want to take over. In the new system, actually the 4 zones can talk in context across different zones. Another important point and feature is very similar to how we upgrade from 2G to 3G phones. The latency dropped drastically, and the response is much faster. And for the 2.0 system, the voice feedback is less than 700 milliseconds. And in the previous versions, it actually takes 1 or several seconds for such response. And the last important thing is that even when we don't have internet connection, when we're in a basement or when we are out in the open, a lot of the times we don't have internet connection. But voice assistant here 2.0 also supports such a scenario. So coming up, I would like to share with you a demo video by an engineer.
Hello， 大家好，我是小鹏汽车智能语音产品经理 Seven。今天由我为大家来演示全场景语音 2.0 的主要功能，让大家一起来感受一下 G9 语音交互的快和自由。首先是可以实现秒内回复的极速对话。打开车窗，打开空调，
正在打开哦。
车灯，
空调打开了。
氛围灯，
好的。
黄色。
氛围灯黄色。
大家可以非常直观的看到，小 P 的反应速度确实非常的快，不仅单个指令执行速度快。小 P 现在还能支持一次性说4个指令，比如关闭车窗、打开空调和香氛，调到24度。
好的，主驾车窗关闭了，空调已打开，并帮你把香氛和温度调好了。
除了响应快，G9 的全车全时对话功能也从时间和空间2个维度带来了全新的交互自由。首先是唤醒方式的自由，以往我们必须要先喊你好小 P 才能继续下达指令。对于很多朋友来说并不友好，而现在 G9 上可以免除唤醒这一过程，直接对小 P 说明确的指令即可，比如打开座椅按摩，按摩力度调高，
正在打开，按摩力度已经最高了哦。
大家可以看到，刚才我并没有说唤醒词，小 P 便知道哪些是我在对他下达的指令。从上车开始，小 P 便会这样一直处于待命的状态，随时响应你的不时之需。如果你说了一句指令，但小 P 没回应你时，你可以尝试在后面再补一句小 P， 比如哪儿有充电桩，小 P。
结果是第几个？
他就会像这样及时的回过神来，响应你的指令。接下来，我和我的小伙伴们为大家一起演示全场景语音 2.0 的另一个重磅功能——多人对话。目前在市面上呀，所有的车型同一时刻下最多只能允许1名用户说话，其他乘客想要下指令则需要重新唤醒。而 G9 应用了小鹏首创的 MIMO 多音区技术，当多人对话开启时，小 P 可以耳听4路，同时满足多个人的需求，并且从对应的位置进行回复。导航去小鹏充电站。
结果是第几个？
万科广场。
欧科。
那我们现在出发，打开车灯，
打开美妆空间，
打开运动模式，
空调关了。
美妆空间打开了，
座椅往前调，
运动模式打开了。
第一个。
好的，主驾座椅向前调了。
大家可以看到，小 P 会对车内每个人说的话进行判断，辨别出哪些是他需要响应的，哪些是闲聊或者打电话，其中有效的指令才会上屏和响应，从而减少对全车用户的打扰。最后为大家来演示多人上下文对话功能。多个人呢，如果有相似的需求，同样不需要重复唤醒小 P， 只需要说我也要，或者直接说出你的需求即可。打开座椅按摩。
主驾波浪按摩正在打开，副驾波浪按摩打开了。
打开空调，
空调打开了，
调到26度。
温度设为
风大一点，
风量设置为2了哟。
好的，以上就是小鹏 G9 全场景语音2.0的新功能演示，希望能给朋友们带来更加自由便捷的语音交互体验。
I'm sure my daughter would be a big fan of this feature because every time I talk to the voice assistant, she copied my command. And then I said, "Girl, you have to reawake the voice assistant to take over." But now she doesn't need to. For the all scenario voice system 2.0, we actually adopted full stack in-house developed second gen voice architecture. We just watched a short video for a demonstration. But in the future, more of our models, including our overseas models, will be able to use the entire second generation of voice system and the architecture capabilities. Actually, we are the first automaker in the industry to develop its own voice capability. It really improves the comprehensive wake-up rate, for example, to 98%, and the noisy background wake-up rate to 97%. The cost of the data for the compatible models decrease by 95% as well. Intelligent voice system will continue to evolve to become more natural, personalized, and emotionalized. It is interesting that when we were developing robots, we considered making an intelligent machine brain. We believe that the future of intelligent speech and machine brain will form a strong combination. That means that increasingly intelligent voice assistant will be a brain that can understand you better in the future. So that was about the full scenario voice system 2.0. I would like to share with you a brand new function that is about customization your smart car. For example, how do we use the vehicle's open-end platform to form a remote intelligent scene that can integrate multiple scenarios, available for operations, and customized settings? Let's watch a short video for a better understanding.
Hi， 欢迎回到我们的座舱，已为您调整座椅，空调也提前为您调整至恒温25度，开启运动模式。坐好了，我们出发吧。行程信息已用短信发给您的爱人，预计15分钟之后到达目的地。即将到达目的地，让我们一起迎接它吧。嗨，工作一天辛苦啦，快来享受您的专属定制吧！已为您调整记忆坐姿和恒温空调。今天工作辛苦啦，已打开您最喜欢的启力幻境香氛。最快回家路线已锁定，让我送你们回家吧。
Making your family happier and making yourself happier. I believe this is a common goal that every single one of us here at XPeng want to achieve. So with the feature we just saw, I believe that XPeng can provide a lot of templates in the future that can help you easily and quickly edit your personalized model if you don't bother to do so. If you are a geeky user, I believe that we can also provide a rich combination of features that allow you to edit and customize. After the edits, you can even share that with your friends so that you can find an intelligent full scenario mode that you like. In the future, we are going to build a platform together with our users to create their own interesting scenarios, and these scenarios can be linked, connected, shared, and redefined for their own smart cars. Today, I would like to briefly share with you some of our latest changes regarding the development of our intelligent robot and our flying car. Allow me to start with a short video to give you some update on the intelligent robot Little White Dragon. To be honest, we have thought a lot about robotics. We are different from many other companies. We started out thinking, why so many companies that are doing innovation in the robotic field, but none of them can really mass produce and eventually apply them to the home. Our robotics system has been developing for 6 years, and we never stopped thinking about the needs robots can meet. How can we balance the cost of the robots, their safety, the adaptability to families? How should we do things right? What kind of development methods should be applied for robots? We have discussed all of those topics. We chose the direction of developing quadruped to verify whether or not the above mentioned can be achieved. For the last year, our Little White Dragon reflected the explorations that we have done. For example, AR projection. The robot can be a TV. As long as there is a wall, you can watch TV, you can interact with them, they can answer questions. In addition, we realized that robots can be a mobile, high-fidelity sound system. It can also be the recorder of our family life. It can take photos and videos. We've done a lot of interesting explorations in anti-shaking capability. How to ensure their safety? We installed elastic fabric joints, silicone skin, and foaming food. How do we ensure their safety and comfort inside a home? When they pass the sofa area, how do they not ruin the carpet? And also, we talked about a lot of other related situations as well. Here, I would like to share with you some of our interesting explorations and findings. The first one is about how to make the robot quieter. Do you know how many decibels a robot has when they walk inside a home? Close to 70 decibels. Very noisy. Our goal is to lower that to within 50 or even 40 decibels. If it is not quiet enough, no one is going to get them or invite them into their home. Second, when we put a four-legged robot into a home, we saw something very interesting. For example, when we two-legged human beings walk to our bedside table, and when we need to turn, we just turn. But for the robots, it's quite difficult. They have to actually walk backwards because the distance from the bedside table to the bed may be very, very narrow. The robot, if they do have a chassis, the turning radius would be too large for them. So how do you equip a robot with excellent obstacle avoidance in a very narrow environment? This is what we have been exploring a lot in the past. In addition, we talked about robot arm as well and their application. Now we have an interesting view. Being able to walk is not really that useful. Let's say, nowadays, when you are presented with a robot, would you choose one that can just walk or one that can act and help you make movements? The arm itself develops the most valuable capability for a robot. So how do we develop it cheaply, safely, and pleasingly? And also, how to make it enjoyable for children? It's something that we've been exploring in the robotics field as well. So for the past 2 years, we try to put a lot of system capability within the robot, and we also have observed a lot of interesting changes as well. such as autonomous driving capability. Autonomous driving for a robot is not just about mobility. You have to be able to have automatic hands, head, as well as mouth as well. And constantly the robot is in motion. How do we maintain that? And how do we maintain human-robot interaction in terms of voice interaction, visual interaction, movement interaction, head interaction, etc.? So that becomes more and more important for the robot to develop a machine brain or robot brain. And we have also considered putting the whole car's R&D system within the robot. How do we fit everything within such a small robot? That is challenging enough, not to mention the power system. A robot has dozens of motors, and it's very tough to combine these motor capabilities while maintaining a low noise level, high reliability, and durability. In the future, we also can debate in a home environment whether it's easier for a four-legged robot to overcome obstacles or for a two-legged one to do so. Should they have single-arm capability or dual-arm capability? Maybe by next year, we can share with you what the future mass-produced version will look like and what capabilities it will have based on our 6 years of thinking and exploration. Alright, our last video is about our flying cars. Now, in the recent month, many of you may have seen our XPeng's Aero HT flying car's first flight in overseas airspace, getting many media attention domestically and internationally. Many of my friends have shared some video to me asking whether or not this is a flying car or a flying machine because it has no wheels. They are right. For the past 9 years, we've been developing flying machines. And for the past 8 years, we've been building cars. And we are now trying to make a car that can fly. It's driving-flying integrated, it's capable of vertical takeoff and landing, it's fully electric and intelligent. Now, the photo that you're looking at right now is our last year's photo. We made some adjustment this year. Why? For example, after we folded the two wings into the car body, we discovered an issue. The height of the wings unfolded was probably less than 1 meter high, and it caused some safety concerns, especially when there is a strong wind that is, for example, category 6 and above. If you land in such a condition, the car body will swing and there will be safety problems. So I'm sharing with you a brand new video with an evolved form that looks closer to our mass-produced version. I would like to share with you two photos. I believe our final production car will look at least 80% similar to what you see in the photos. So this is the driving mode and the other is the flying mode. In the flying mode, we have 4 axes and 8 propellers. Coming up, I would like to share with you some real data and videos that we collected from our R&D stage. First, we have changed from the original 2 rotors to a distributed multi-rotor structure. We can see that in the updated structure, there's higher safety advantage. The most important thing is that even if one propeller fails, there's still no problem. We're now trying to test to see if there's going to be any problems with two failing propellers. Second, its overall size will be smaller after unfolding, so there will be less restrictions on the takeoff and landing. But unfortunately, it's not as small as you think. Many people thought that in the middle of a traffic jam on a highway, they could just unfold and fly out. Sorry, you might have to clear the road before you do that, because the takeoff will still require the size of about half a basketball court. Now, maybe I can share with you a short video to see that in the safety system, as you can see, one of the propellers is failing. But no problem, we still are able to fly steadily. This is actually very difficult to achieve. To be honest, safety is our first priority, and it's most important and most difficult to do. But it's something that we must do well and do right. Many people say, even though I can drive, I've never flown a plane. Do I need to learn to fly a plane? There's no need. We have added a lever to the current steering wheel. This makes it very easy for any people who can drive to learn how to fly this car. It may take as short as only 1 day. In the past year or so, how to let people learn quickly how to fly a plane safely and reliably and stably, it's something that we have done a lot in. As you can see, through this double keyboard with this gear lever, the simple addition can allow you to do all those things. Let's check out a video of how to move a car.
各部门准备 X3 首次飞行实验，现在开始。
可以进行航检检查。上高压电。飞控质检已完成。
FCU 完成。
无异常。DCU 已收到无异常。进入姿态模式，可以准备起飞。3、2、1，起飞。5米、10米，保持悬停。悬停时间30秒。执行前飞动作。飞行稳定，态正常。执行悬停回转动作。当前飞行高度10米，可以挡回起降点。准备着陆10米，5米，3、2、1，着陆。
Allowing a 2-ton car to fly at the same time is a huge challenge. You may not know, but this car is actually much bigger than the G9, and it only takes 2 passengers. However, sending 2 people of less than 200 kilograms into the sky has already been pretty exhausting for us. First of all, the flying car needs to be very light, but the range has to be as long as possible, so the battery needs to be powerful enough to last hundreds of kilometers. Unfortunately, it's only able to fly maybe a few dozens kilometers. But we believe it will be the world's first flying car that can drive and fly at the same time, that are fully electric and intelligent. Some of the challenges that we face right now include the difficulty of flying a car that weighs nearly 2 tons. The difficulty level is over 100 times more than flying a drone that weighs hundreds of grams because of the high power requirements. The entire rotor diameter of the flight control is nearly 3.5 meters. The inertia is so huge for the rotation. How do we solve that? How do we tackle the NVH level inside and outside of the car? And how to let everyone enjoy the experience of flying in the air as well as driving? We were really excited when we saw it at the scene, because we used to fly the machine that weighs hundreds of kilograms. None of them were more than 1 ton. However, next year we are expected to actually drive and fly an engineering test vehicle. These are the great challenges that we experienced for the past year. Okay, this is the last page. A lot of people think that I'm doing something very challenging, but I see that I'm doing something highly technological. I hope to make our driving in the future more easily. We can be released from manual driving. I hope that our car can fly in the future, and I hope that many of our car technology can be used in the robotics field to revolutionize our mobility in the coming 2 to 3 decades. None of those tasks is easy. But what I would like to say is, without patience, without perseverance, we will never be able to achieve revolutionary changes. I've seen a lot of great companies, the peers of ours, have spent decades to make the impossible possible. They make their friends and investors happy, and that's what we aim to do as well. I'm convinced that we will continue to stick to our founding philosophy, using technology and innovation to meet the expectations of our customers and friends. We definitely will overcome today's difficulty, and hopefully we can make our friends proud of XPeng. And I hope that XPeng can be also proud of our friends as well. Thank you all for joining today's event. I look forward to seeing you on next year's Tech Day. Bye-bye.